Alright, we're on. This is the review for the first Concurrency Geometry Quarterly Exam. Your exam will be Thursday, November 5th. Here are your answers. Let's get started. Parallel lines cut by a transversal. You have to ask yourself, are these the same or are they different? They're both obtuse, so they're the same. If they're the same, you set them equal to each other. If they were different, you would add them to equal and solve the equation. We get x equals 15. Answer the question. The question is asking what x equals 15. If it asks you what other the angles were, you would substitute the 15 for the expressions for x. Number 2, again, we have a cube, they're the same. So if they're the same, we set them equal to each other. Solve the equation. Isolate. We got 54 equals 12x. We divide by 12. And we get 4.5. Can x be 4.5? Can it be a decimal? Of course it can. It's asking what the value of x is. 4.5. Again, if they were different, they would add to equal 180. Which of the following properties is not always preserved under a rigid motion? A rigid motion is a reflection, as a rotation is a translation. It is not a dilation. It keeps the size the same. It keeps the angles the same. It does not keep the orientation the same. A reflection is a rigid motion, but the orientation changes in a line reflection. Which of the following is not a rigid motion? Well, like I just said, a rigid motion keeps the same angles, keeps the same size, keeps the same shape. Dilations is not a rigid motion because it changes the size. Reflections, rotations, and translations are. Which regular polygon has a minimum rotation of 45? To determine the minimum rotation of a regular polygon, we use the formula 360 divided by the number of angles. So we do, for choice 1, we would do 360 divided by 8. For choice 2, we would do 360 divided by 10. For choice 3, we would do 360 divided by 6. And for choice 4, we do 360 divided by 5. If you don't know your names of your different polygons, it's in your key understandings. This is 45, 36, 60, 72, which has a minimum rotation of 45, choice 1. Keep in mind, this is the minimum rotation. All multiples of 45 will also carry the polygon onto itself. Number 6, a regular pentagon is shown in the diagram, and it's asking the same thing. What's the minimum number of degrees that must be rotated? Well, the formula is 360 divided by the number of angles. 360 divided by 5 is 72. Again, it's a minimum rotation. You could also multiply that by any value to get another value. 7 is just knowing how to do a construction. If you know how to construct an angle bisector, you know you first draw an arc from the vertex, and then from each of these points, you draw an arc, making choice 3 your angle bisector. It's a constructions question without you actually having to do the construction. Number 8 is very similar. You could also just look at what this is. This is an altitude. An altitude extends from a point and is perpendicular to the base. And it's the same construction as perpendicular line through a point. You start at the point, you draw an arc that hits the base twice, and then from there, it's your perpendicular bisector. In the diagram below, triangle ABC is shown with AC extended through point D. BCD is 6x plus 2. BAC is 3x plus 15. And ABC is 2x minus 1. Exterior angle of a triangle. Exterior angle theorem. The two interior angles must add to equal the exterior angle. The two non-adjacent interior angles must add to equal the exterior angle. Once we set it up, we solve it. We combine it like terms. We bring all x's to one side. We isolate. We add or subtract first. We get x equals 12. The question's asking for the value of x. Well, x is 12. Number 10, we have everything labeled for us. Again, we know the two interior angles, the two non-adjacent interior angles, must add to equal the exterior angle. So, 4x minus 5 plus x plus 40 must equal 6x plus 20. From here, we solve the equation. We combine by terms. We bring all x to one side. We isolate, we add or subtract first. We get x is 15. Make sure you answer the question. It's asking for QPT. Well, this is QPT. So I have to do 6 times 15 plus 20, which is 110 degrees. Eleven is recognizing your transformations. A series of 3 transformations are performed. Identify each of these transformations. A, triangle ABC to A prime B prime C prime. Well, how are we going from here to here? Well, you have to identify what type of transformation it is for starters. It's a slide. It's a translation. Now, be specific. Understand the pre-image does not have the prime. So you're starting at A, and you're going to A prime. You have to go in that direction. When I'm doing a translation, I always list the x-coordinate first. I'm going negative 1, 2, 3. And my y is 1, 2, positive. Now, triangle A prime, B prime, C prime to A double. B double and C double prime. So now I'm going from the green to the red. Well, again, you have to look at it and identify what's going on. That's a reflection, and it's a reflection in the y-axis. I can't really do much for it. You have to be able to see that. The y-axis is a line of reflection for those. Finally, to the triple prime. Now we're going, probably should use black for that. And I'm going to. Now I'm going from the red to the black. You have to identify, again, what's going on there. That's a rotation. How much of a rotation it is? It depends how many quadrants it's moving. To the left, it's moving 1 quadrant, so it's a rotation of 90. Is triangle ABC congruent to triangle A triple prime, B triple prime, C triple prime? Is the blue congruent to the black? Yeah, it is. Why? Because all of these transformations are rigid motions which create congruent. You don't have to word it exactly how I did. Just make sure you get the point across. Identify a single transformation that would perform on the black triangle would result in a triangle that is not congruent. The only transformation that is not congruent to the original is a dilation. So you can say any dilation. I'm going to arbitrarily choose a dilation of 2. You can say 2, you can say half, you can say negative 7.2. Say whatever you want. That's that. Understand and identify your transformations. In triangle ABC, I'm talking about the angles of a triangle. The angles of a triangle. Add. To equal 180. Solve the equation. Combine like terms. Isolate, add or subtract first. Divide last. 216 divided by 12 is something. How does 18 sound? Now, it wants me to determine what type of triangle it is. To do that, I have to substitute that value in to find each angle. So it's 3 times 18 plus 1, 4 times 18 minus 17, 5 times 18 minus 20, which gives me 55, 70. It has two congruent angles, so it's isosceles. It's not right because it does not have a 90-degree angle. It's not stellene because they're not all different, and it's not equilateral because they're all not the same. And of course, equilateral angles, equilateral triangles, have them all being 60. Ratio, they're next behind it. Same type of thing, the angles of a triangle. So it's 2x plus 3x plus 5x equals 180. This will be a lot simpler. 10x equals 180, divide by 10, divide by 10, x equals 18. Again, I need to know what the angles are, so I'm going to substitute in. 2 times 18, 3 times 18, 5 times 18. 36, 54, 90. What type of triangle is it? It's a right triangle because it has a 90-degree angle. It's not obtuse because it does not have an obtuse angle. It's not isosceles because it does not have two congruent angles. It's not acute because they're not all under 90. If perpendicular bisectors of the sides of a triangle are drawn, which point of concurrency will be shown? You need to straight up know what each point of concurrency is called. Look up your key understandings. The two long ones are the two right angle ones. Your altitude one starts with a vowel. Your perpendicular bisector one starts with a consonant. I'm going to ask one more question about it. Which is the median? It's one of the shorter ones. It's the central. Study them. It's your key understandings. You need to know the name of those four. Two angles form a linear pair. You need to know that a linear pair looks like this. And you need to know that a linear pair is supplementary, which means it adds to equal 180. Now it says one angle is 42 less than twice the other angle. Well, that goes back to what you learned in Algebra 1. You need to create expressions. I don't know what the other angle is, so I'm going to call it x. The other angle is 42 less than twice that. Twice that, 42 less than that. Those are your expressions. That goes back to Algebra 1. I know you hated that topic back in Algebra 1, but you can see it sometimes in geometry. Now that I have the expressions, if they're supplementary, I'm going to add them to equal 180. 3x minus 42 equals 180. Solve the equation. 3x equals 222. Divide by 3. X equals 74. It's asking for the measure of the larger angle. I don't know which one's larger. This one's 74. This is 2 times 74 minus 42, which is 106. 106 is the larger angle. Number 17, it says angles are complementary. You need to know what complementary means. That's why you're studying right now. That's why I look at this video. So you can learn right now, you can practice it, you can memorize. That complementary means adds to equal 90 degrees. You get that in a right angle. These two angles would be complementary. One angle is 34 degrees smaller than 3 times the larger angle. So we have one angle, we have a second angle. I don't know what the first one is. The other one is 34 degrees smaller then 3 times that. 3 times that minus 34. I know that they're complementary, so I add them to equal 90, and I solve the equation. Algebra is good. Solve it. X equals 31. Which one is the smaller angle? If you're not sure which one is smaller, plug it into both. X is 31. 3 times 31 minus 34 is something. I believe it is 59. Which one is smaller? Know what complementary, supplementary mean? Know what linear pair is? Now we got some constructions. Unfortunately, I cannot do constructions on the smart board here, but I can do it freehand. You will not do it freehand. Do not try to do it freehand. Do not think about doing it freehand. Use your compass and straight edge to do your constructions. I want to construct an altitude from vertex B. So I'm going to start by putting my eye here, and I'm going to swing an arc that hits twice. From there, you do your perpendicular bisector. From here, you swing an arc more than halfway. From here, you swing an arc more than halfway. It looks so ugly doing it freehand, but that is how you do it. So practice it. Don't just watch me do it, practice it. If you practice your constructions, you'll get them right. For the median, it wants a median from vertex A. So that means I need to connect this point to the midpoint of BC. To find the midpoint of BC, I have to do the perpendicular bisector from BC. So I put my eye here, I draw my arc, I then put my eye here, and I draw my arc. Hopefully it's not going to be way off. From there, I draw in my perpendicular bisector. So again, I just drew a perpendicular bisector. That was really bad. I just drew my perpendicular bisector for segment. BC. To construct a median now, I connect the midpoint, which I just found, with the vertex, and there's my median. Again, do not do this freehand. Do not even try and do it freehand. I obviously just failed at it pretty poorly. So use your concentrators, take your time with it, practice it. Inscribe square. Again, another construction. I'm going to do it freehand. Don't you dare. For square, you start by drawing an arbitrary diameter. You then construct a perpendicular bisector. You put your eyes here, and you draw your arc. You put your eye here, and you draw your arc. And then you draw the perpendicular bisector. Once you do that, you have 1, 2, 3, 4 points on the circle. Notice, I don't care where it intersects, I care where it hits the circle. Once you have them, use your straight edge and connect the 4 points. It should be touching the circle, and that's your square inscribed in the circle. Again, don't you dare do what I'm doing right now. Use your compass and straight edge. For the hexagon, which is the same as the equilateral triangle inscribed within a circle, instead of starting with an arbitrary diameter, we start with arbitrary radius. Now that I have this point, I measure out an exact radius, and I draw an arc. This is going to be awful. I'm just warning you. Ooh, maybe I should look at my paper to see approximately where it is. So it doesn't look as bad. Now that I do that, I take this point, I put my eye here, and I draw an arc. Now that I have this point, I put my eye here, and I draw an arc. 1, 2, 3, 4. Now that I have this, I draw an arc. Now that I have this, I draw an arc. Now I have 1, 2, 3, 4, 5, 6. I connect for a hexagon, I connect all of them using a straight edge. Not bad, considering it's freehand. If it was equilateral triangle, you would connect every other point. That black would be the equilateral triangle. Am I done yet? No. Composition and transformations. List your points vertically. A, B, C, D. A is -4, 5. B is 1, 5. C is 1, 2. And D is -6, 2. Always start at the right. Reflection in the line y equals x. You need to know your rules. Know your song, you know your rules. You don't know your rules, you don't know your song. Good luck to you. Y equals x, switch the points. Now I take the new points and I reflect them in the x-axis. Keep the axis you're reflecting over. Keep the x. Negate the y. Sometimes you have to graph it, sometimes you don't. In this case, it just says to state the coordinates. It's not asking me to actually graph it. So this is A double prime, B double prime, C double prime, and D double prime. The only one where you have to use the graph is a rotation or a reflection in a line other than the x-axis or y-axis. Same type of thing here. I got my M, E, T, Z. I got -4, 1. I've got 0, 5, 2, 3. 4, -4. I want to do a rotation of, whoops, not 90, but 270. If you know your song, you know rotations turn, use a graph. So I got to plot the points. I've got M is -4, 1. I've got E is 0, 5. I've got T is 2, 3. And I've got Z is 4, -4. Again, use a straight edge. I want to rotate this 270. So my rotations, my positive rotations are always to the left. So that's 90, 180, 270. I'm now going to list the new points. M is now +1, +1, +4. E is now +5, 0. T is now +3, +2. And Z is now -4, -4. Side a little bit here. I turn it back. Now it wants me to do a translation. If you know your song, you know exactly how to do a translation. Translations add. So I'm going to add -2 to my x values. I'm going to add 4 to my y values. It does ask me to graph this. Whoops, and 4. It does ask me to graph this. I made a mistake, didn't I? It's supposed to be 3, -2. Oh no, we made a mistake. That's awful. So that's going to change this. Let me just do this 0.4. So that makes this point 1, 2, and this point -6, 0. So now I'm going to plot those. -1, +8 is M double prime. 3, 4 is E double prime. 1, 2 is T double prime. And -2, 4, 6, 0 is Z double prime. Connect them. It should look correct. It should look like a rotation and a translation. Looks good to me. So just be careful, obviously. You might make a mistake, but also looking at the picture is a good way to make sure if you didn't make a mistake, you can catch it. In the triagram below, triangle GJK, H is the point on GJ. That's fantastic. I care about this though. HJ is congruent to JK. So I mark the sides and the angles opposite them. I see a triangle, and I know in these triangle problems I need to look for linear pairs and angle the triangle. X plus 70 equals 180. Combine like terms. Solve the equation. Either the 55. Again, we also need to look for linear pairs. I see a linear pair. So 180 minus 55 is 125. Now I see another triangle. Angles of triangles. I have 2 angles of the triangle, so I can find the third one by adding them to equal 180. X equals 27. Alright, I feel like I fill in everything. It's asking whether triangle GHK is isosceles. That's the red triangle. And justify our answer. Well, are 2 angles the same? No, they're all different. All of the angles are different. It is the one more. In the diagram below, triangle ACD, B is a point of AC such that ADB is an equilateral triangle. That is music to my ears. Because when I see an equilateral triangle, I know, without doing any work, that all the angles are 60. And hey, I see a linear pair. Because I'm looking for it. Alright. It also says that DBC is isosceles with DB being congruent to BC. DB, BC. As soon as I mark those, I mark the angles opposite them. Now I see angles of triangle. 120 plus X equals 180. Combine like terms. X is 30. So each of these angles is 30. Angle C is 30. I went through this kind of quick. You should not go through it kind of quick. You have the luxury of pausing this. You cannot pause me in real life. You can pause this. You can look back through it. Do what you need to do. Not only practice these problems, but find more problems like this in your old worksheets and practice them. If you're able to do them in practice, you'll be able to get them right on the exam. If you do not practice them, well, can't make any promises. Again, here are your answers. The exam is going to be on Thursday, November 5th. At least that's for my class. I don't know if anyone else will be watching this. And that's all I got for you. Study, practice. You also have my songs on the YouTube page, although all we've done so far this year is transformations, but utilize that. I am done with you. I am turning you off.